Guys, I'm back with example number 5 on solving trig equations. In this case, we have an equation which looks more like a quadratic type of an equation. So in order to find the values for x, again, x is restricted between 0 and 360 degrees. That means we don't have to add 360k or 2 pi k all the way at the end. But guys, how are we going to solve this equation? Keep in mind, our goal is to isolate the cosine function in this case because it involves cosine, and then finally solve for x either using the unit circle or using our calculator. But looking at this equation, obviously it is almost like it is very difficult to isolate this for cosine x. Guys, we cannot really solve this easily for cosine x. One has to think about some other methods, but those methods are methods that you have already learned in algebra or in pre-calc. Guys, whenever you have a quadratic equation of this form, you already know what you have to do. The first thing you want to do is you want to get it converted into a standard form. By standard form, I'm trying to remind you that it's ax squared plus bx plus c equal to 0. So that is the first thing that we like to accomplish. Once we have it in the standard form, then we can see if we can factor the left hand side. If we can factor it into product of 2, then we can solve for each individual piece. Or if we cannot factor, then one has to use the quadratic formula. But there's a square here that already tells me that it is a quadratic form. So guys, let us first try to get it in the standard form, which is very easy. You just subtract 1 from both sides. When we do that, we get 2 times cosine square x plus cosine x minus 1 equal to 0. And guys, keep in mind the reason why we are doing this is because there's no direct way of isolating cosine x. And that is the same thing we do when we go from solving linear equations to quadratic equations. With linear equations, we're able to isolate x or any variable by doing some mathematical manipulations. But then when we start working with the x squares, x cubes, and so on, then there's we are not able to isolate x easily. So one has to kind of look into other methods. And one of the methods is if we convert it into standard form, and then we try to look for linear factors. Guys, this equation, if you want to relate it to an algebraic form, it's more like this ax squared plus bx plus c, and then we want to write the factors for this. Guys, you know, for any quadratic form of this type, we just want to write the factors. We just draw these two parentheses, and then of course there's the process of doing the factors, there's splitting the middle term process and all those things. But for something as simple as this, I think we won't struggle, or you won't struggle too much for finding the two linear factors. You already know that here I'm going to have a 2 cosine x, and here I'm going to get a cosine x, because it is guys, you can think of this as 2x squared plus x minus 1 equal to 0. How would you write the factors? You draw these two parentheses, and then what goes here? 2x and x. That is something we already know because 2x times x is 2x squared. Here it is x and x, but here instead of x, I have this whole trig function, cosine square and cosine. Okay, so that's why I have a cosine x and cosine x. Then you have to come up with other two numbers that go right here, so that when you distribute everything, you get the previous step. Guys, you may have to play around with some numbers. I already have a -1 and +1. And if I distribute, I get this time this gives me this, and this time this is 2 cosine x minus cosine x gives me the middle term, -1 plus 1 gives me -1. So I just verified that these are the right two linear factors. So once I have these two linear products or linear factors, and their product is equal to 0, from here we know that 2 cosine x, well, we set this equal to 0 using the 0 product property, or cosine x can be plus 1 equals to 0. So you set this equal to 0, and you also set the other one equal to 0. From here, guys, this quadratic form transform into two linear pieces. That is what usually happens when you work with a quadratic equation. You kind of trim it down or break it down into two linear pieces. Then we know how to solve simple linear equations. So from here, you just can easily isolate the cosine x. You have to take that 1 to the other side and divide both sides by 2. I think I can do it in one step. So I get cosine x is 1/2, or in this case, I get cosine x is -1. So cosine x 1/2 means, we know it's positive. So that means we know cosine is positive in the first quadrant, and then it is positive again in the fourth quadrant. So for this particular value, we only have to look into the first and the fourth quadrant. And then cosine is negative in the second quadrant and in the third quadrant. So for this value, we have to look into the second and the third. Okay. So I'm looking at my unit circle and I'm looking in the first quadrant. In the first quadrant, I can quickly see that one of the angles for x, that gives me 1/2 for cosine. Keep in mind, guys, cosine values are the x values on the unit circle and the sine values are the y values. So I get a 60 degrees as one of the values, guys. Then I also have to look into the fourth quadrant, because cosine is positive again in the fourth quadrant, and I get a 300. Both of these values are between 0 and 360, so they are both valid answers. Then, excuse me, then the second one is -1. For -1, I have to look into the second and the third quadrant. In the second quadrant, the only value where I see -1 is cosine of 180, so it is 180 degrees. Guys, if I look into the third quadrant, there's no value for cosine. That gives me a -1. So I think those are the only three values that actually solve this equation. Solve this particular equation, that is 60 degrees, 300 and 180 degrees, and all these three are between 0 and 360. So we don't have to really do any extra work of finding other values, but we know they are periodic functions. We will have infinitely many solutions if we keep on adding 360 or subtract 360. But guys, that's it. This was example 5. It was a quadratic form, so we had to solve this like we would solve a quadratic equation. It was not too complicated to find the factors. We were able to find the factors. From factors, we were able to look at the unit circle and find the angle. Okay, example 5 is done, guys. I'll see you next time with another example. Till then, take care.